All right, welcome to day 3. Homework tonight is packet page 18 and 19. We're going to look at some other relationships with segments that show up in circles. You have a warm-up to be putting in your Wednesday box on your warm-up sheet. So go ahead and pause the video, do the warm-up. When you hit play, a box will pop up for you to submit your answers. So CE is x minus 4. AE, we have x minus 3. DE is x plus 3, and BE is x. So we multiply the parts of our chords that are on the same chord and set them equal to each other. So we'll have x times x minus 3 is equal to x minus 4 times x plus 3. Distribute the x over here, we get x squared minus 3x. If we FOIL out here, we'll distribute the x to both, we'll distribute the negative 4 to both. So we'll get x squared plus 3x minus 4x minus 12. We can subtract the x squared from both sides, and notice the x squareds go away. So this will give us minus 3x is equal to, if we combine like terms over here, we end up getting negative x minus 12. We'll add the x over to give us negative 2x equals negative 12. And when we divide by negative 2, we get x equals 6. Reread the question to see if they wanted x or subbing in, and we just wanted to find the value of x here. Moving over to the homework, we're doing similar idea on this question, just a little simpler question. The 6 times 5 should equal to 7 times x. 7x equals 30, divide the 7 over. That does not come out nice as a decimal, so leave it as a fraction. In 2, they told us CD bisects AB. Well, a segment bisector implies a midpoint, which implies 2 congruent segments. Therefore, if AB is 8, AE and EB should both be 4. Label CE 2, and then we can call DE x, the other part we don't know. You'll have 2x equals 4 times 4, so x equals 8. That tells us what DE is. Then add the DE and the EC to give us CD is 10. Three was very similar to the warm-up. Label your parts. You got to distribute and FOIL out. Subtract the x squareds from both sides, then get all the x's on one side, so we get x equals 4. In 4, we have 2 chords that are perpendicular to each other. So the things that we know are that AE and BE must be congruent. About 90% of the time in this type of picture, you end up having to connect the center to one of the endpoints of that chord, which would be a radius, and it will form a right triangle. They told us that OD was 10, so that means we also know OB, that hypotenuse, had to be 10. And I drew it to the right. You could have drawn it to OA and worked with the triangle over there. If CE is 4, well, that means that OE would have to be 6, because together they'd have to equal 10 for the radius. Do your Pythagorean theorem to find what BE is, and then AB should just be double that, because AE and EB are the same length. In 5, we've got a diameter and a chord that are perpendicular again. So we know that AB gets cut in half. So if AB is 30, each of those are 15. If CD is 34, that means we know each radius is 17. So when we draw on that radius from either OB or OA, just got to pick one of them. I chose OB, label it 17. Pythagorean theorem tells us that OE, which I labeled X in the picture, is just 8. In 6, we had to draw the picture, which makes it a little bit trickier. The distance to your center of your circle just ends up being the same picture that we've done in the last 2, because we would need it perpendicular. So you've got the chord there, CD. So here's maybe C, here's maybe D. It's 8, so it gets split in half, 4 and 4. If the radius is 12, that ends up being the hypotenuse. When we do our Pythagorean theorem to find that length x, which is the distance it is from the center of the circle, we end up getting a radical that's not nice, so do a menu number factor, and you eventually get 8 square root of 2. All right, that's it for the homework. We're going to be going to packet page 14. So we worked with intersecting chords and diameters that are perpendicular to chords in the previous class. Today we're going to look at a tangent secant segment and a secant secant segment. In both of these cases, so first off, I guess I should say a secant, remember, hits the circle twice. So in the left-hand picture, PA is a secant, and in the right-hand picture, PA and PD are both secants because they hit the circle twice. A tangent hits the circle in one location. So in the left-hand picture, PC would be considered a tangent. In both of these cases, the setup that we will do is in a given segment, you do the outside part times the whole is equal to, in the other segment, the outside times the whole. And that'll be true over in this other one as well. We'll do outside times whole is equal to outside times whole. So let's see what we mean by that. So in the top segment, PA, the outside part would be the part that's outside the circle. So you would be doing PB times the whole thing for that segment, which would be PA. So we do the outside part times the whole part. And that equals outside times whole for the other segment. Well, PC is the part that is outside times the whole thing, which also happens to be PC. So we end up with PB times PA is actually equal to PC squared. And that's because the outside and the whole are the exact same thing. Over in the right-hand side, if we think of our outside times whole equals outside times whole, we'll start out on the top. Our outside would be PB times our whole thing, which is PA. And that's equal to our outside part PC times our whole part, which is PD. So outside times whole equals outside times whole. And then once you have that, you would just solve for wherever the x is in the picture. Now, why does this work out? Okay, this bottom part, you're never going to be quizzed on or anything like that, but in math, it's just good to know where things come from, that it is not just being pulled out of a hat. So imagine we connected B and C here, and we connected A and C. Well, notice angle A is inscribed and opens up to arc BC, and PCB is also inscribed and opens up to arc BC. So they're inscribed angles opening up to the same arc, so therefore they are equal to each other. So I want us to think of the big triangle there, APC, and the right-hand triangle as well, BPC. Right now, the big triangle and that right-hand triangle share one angle. Well, notice they also both have angle P, so that's reflexive. So now they have two sets of angles that are congruent. That makes them similar. So triangle APC is similar to triangle. The A matches with angle C in the other one. The P matches with the P, and then the B matches up. Well, if triangles are similar, their sides are proportional. So that means that PB over PC should be equal to PC over PA. And if you cross multiply that, we would get PA times PB is equal to PC squared, PC times PC. And notice that matches with what we had above. So that's why our formula works out, because of similar triangles. Now we can do a very similar scenario here, no pun intended. So angles A and D are inscribed and open up to the same arc. And then P is a reflexive angle. And the triangles we're working with are DPB and ACP. So we can say that triangle ACP is similar to triangle DBP. So therefore PC over PB is equal to PA over PD. And if we cross multiply, that means PB times PA is equal to PC times PD. Well, notice that's just outside times whole equals outside times whole. So that's just a way of showing you why it works. Again, that bottom part, you're never ever going to have to do. I just want to show you that it's not just coming out of thin air, it's using things that we have already seen this year. So the main thing to know from this page is when you see two secants or a secant and a tangent, you want to think outside times whole equals outside times whole. So let's look at our first actual problem over on the next page. They tell us that CD is 6. They tell us that CE is 14. And a good way to label that is with a bracket. They tell us that CB is 7. And then the things we want to find are AC and AB. Well, our formula is set up as outside times whole equals outside times whole. So let's call our X as the whole for right now. And then we'll figure out, because that matches our formula well, and then we can figure out what the things we need are after. So our outside is 7 times the whole, which is X, equals our outside 6 times our whole, which is 14. Well, that's going to give us 7x is equal to 84 when we multiply that out. And if we divide by 7, we just get x equals 12. Well, the two things we wanted to know were AC and AB. The x represented AC, so that one's done. AB was just this part here. Well, if x was 12 and BC is 7, 12 minus 7 just tells us that AB is 5. So if x is not already drawn in the picture, sometimes it will be, and you'll just have to use what x is labeled as. But if x is not already drawn in the picture, put it as the thing that matches up nicely in our formula, either the outside or the whole, whichever we're working with. All right, going down to the bottom, we've got an outside is 12 times a whole that we don't know. So 12 times x equals an outside, which is 10, and our whole is not labeled for us, but we can figure it out. The 10 and 14 gives us 24. So this will give us 12x equals 240. We'll divide both sides by 12, and this will give us that x is equal to 20. But is x what we wanted? We wanted CB, and x is CA. So if that whole big thing is 20, if BA is 12, do the 20 minus 12 and get that CB is just 8. Notice in choice 3, x is already drawn, so we've got to work with it as is. We want to do outside times whole equals outside times whole. So in the top part there, outside is 8 times. Now people make a lot of errors when identifying their whole. If this was, say, 5, we would say our whole is 13. And that's because we added them together. So to label our whole, we've got to label it as 8 plus x. I see a lot of people will call it 8x, and that's not correct. That's multiplying them. It's 8 plus x to represent the whole. So when we do it times the whole, we've got to make sure that 8 plus x is in parentheses. And then on the bottom, our outside is 12 times the whole, which is also 12. We'll distribute the 8. That'll give us 64 plus 8x. And over on the right, 12 times 12 is just 144. Subtract the 64 over. We get 8x is equal to 80. And if we divide by 8, we get x equals 10. Reread the question, see what they wanted. We just wanted to find the value of x, so that's it. Moving over to page 16. We'll label what we know. We've got PB is 10, BC is 8. We want to find PA. Well, we're going to need the whole, so let's also label the whole 18. So if we do outside on top, it's x, times the whole, which is x, equals on the bottom our outside, which is 10, times the whole, which is 18. X times x is x squared. 10 times 18 is 180. Undo a square by doing a square root. If we do square root of 180 on our calculator, we would get something that's not nice. So take a moment, do a menu number factor for 180, and see if you can break down that radical. So we should have 2 times 2 times 3 times 3 times 5. Circle each pair, one from each pair goes out front. So that's 2 times 3 square root of 5, or in other words, 6 square root of 5. They wanted to find PA, which is what we ended up calling x, so PA is just 6 square root of 5. Over on the right, we want to find x. X is already labeled for us. Let's identify what our wholes are. Remember, we're adding them together, so this is x plus 13. And our whole here, 3 plus 7, would give us 10. So we'll start with our outside of x times our whole of x plus 13 equals our outside of 3 times our whole of 10. If we distribute the x, we'll get x squared plus 13x is equal to 30. We've got both x squared and x, so we want to get everything on the same side so it's equal to 0. So we'll subtract that 30 over. So that's x squared plus 13x minus 30 equals 0. When we factor this, our goal is to add to 13 and multiply to negative 30. So we've got to think about two numbers that will do that. And that'll be a positive 15 and a negative 2. Because 15 times negative 2 is negative 30, and 15 plus a negative 2 would give us positive 13. So we set those each equal to 0. We'll subtract the 15 over, and we get x equals negative 15. And we'll add the 2 over, we get x equals 2. So we got a negative answer for x. We need to see, does that give us a negative length in our picture? Well, we had a length that was x, so yes, we would have to get rid of that negative 15. If, say, our length was like x plus 20, well, then negative 15 is okay, because that would give us a positive back. So we have x equals 2. The question just wanted us to find x, so that's our answer. Moving down to number 6. Let's label what our wholes would be, because we would need them. This will be x plus 13. 4 plus 8 will give us 12 on top. So we'll do our outside of 4 times our whole of 12 is equal to our outside of x times our whole of x plus 13. 4 times 12 will give us 48. If we distribute the x, we get x squared plus 13x. Subtract your 14 or 48 over, and you get 0 equals x squared plus 13x minus 48. So we're looking to multiply to negative 48 and add to 13. So two numbers that would do that are 16 and negative 3. Now remember, the way you can figure that out on your calculator if you're not sure is you go to a calculator page and you take the number you want, or the thing you want to multiply to, the negative 48, and divide it by x. So in the graphs page, I think I said calculator page a second ago, but you want to go to a graphs page, sorry, and do negative 48 divided by x, hit enter, and then do control T. The pairs of things in your table are the ones that will multiply to negative 48. Then you've just got to find a pair that will add to positive 13. We'll set those each equal to 0. So we'll subtract the 16 over. We'll get x equals negative 16. We'll add the 3 over. We get x equals 3. So we've got to think about that negative 1. It doesn't make any segments negative or 0. Well, the x is a segment, so we can't have that as negative. Again, you don't just automatically reject a negative, because if we didn't have x, if it was like x plus 20, well, that's okay, because negative 16 plus 20 is a positive. But because just x was a segment, that's why we'd have to reject it. All right, we want to find AB, and that'll be our outside and whole part for the top one. So we'll have x times x equals, we'll need our whole here. If we add those together, we get 28. So outside is 7 times the whole of 28. X times x is x squared. 7 times 28 will give us 196. If we take the square root of both sides, technically when you take a square root, you have to put a plus and minus out front. So we would get plus and minus 14, but we reject the negative 14 because x was a segment. So we'll just take the 14, so AB is 14. Moving over to page 17, our last page for this video. We'll label the things they tell us. We've got BC is 5, we've got AB is 7, we've got DC is 3. We want to make sure we have our outsides and wholes labeled so we can set up our equation. So this whole would have to be 12. This whole we'll call x. So we'll do our 5, which is the outside, times the 12, which is the whole, equals the 3, which is the outside, times the whole, which is x. So this will be 60 equals 3x. And when we divide by 3, we'll get x equals 20. Well, now we got to make sure we answer what they're looking for. They want us to find CE. CE was the whole thing. That's what we just found, 20. We also want to find DE. Well, if the whole is 20 and you got the 3 out on the outside there, 20 minus 3 would give us 17. In 9, notice they're calling it circle P. That means we know P is the center, meaning that BA is a diameter and BP and AP are radii. So if AP is 4.5, we automatically know that BP is also 4.5 because they're a radius. BC is 16. We'll label this X because we'll need it for the outside and the whole. We've got the 16 for our outside here. Let's make sure to label our whole. The 4.5 and the 4.5 give us 9. 9 and 16 gives us 25 for our whole. We're now ready to set up. Outside times whole equals outside times whole. So outside of 16 times the whole of 25 equals outside times whole, which is both x for the other one. 16 times 25 will give us 400 equals x squared. Take the square root of both sides. When you take a square root, the side that had the number, you technically need a plus minus out front. So that's going to be plus minus 20 initially, but x was a length in our picture. We can't have a negative length, so we'll just have x equals 20. So that's what DC was. DC is just 20. And our last one for today, down in 10, we'll label the things they tell us. AB is x, BC is x minus 4, CD is x plus 4. So the x is going to be our outside and the whole on top. On the bottom, you've got the x minus 4 is the outside. We'd have to add those together to get our whole. Well, when you add them together, you'll have 2x and then the -4 and the +4 wipe out. So we can do our outside times our whole on top, x times x. Our outside is x minus 4 times our whole, which was 2x. X times x gives us x squared. Usually we see the thing out in front of the parenthesis, but here we're multiplying it after. It still just distributes through. So we'll have 2x squared minus 8x. We have both x squareds and x's, so we want to get it all on one side, so it's equal to 0. We want to have a positive x squared. So because of that, we'll subtract the x squared over to the right, because that'll leave us with a positive x squared minus 8x. Notice there's no constant term on the end. A constant term is a term that doesn't have a variable, like a +7 or a -2 on the end. We don't have that, so we want to see, can we take out a greatest common factor? Both those terms have an x that we can pull out. If you take an x out of the first term, we're left with x. Take an x out of the second term, you're left with -8. Well, just like our other ones, we'll set these each equal to 0 now. That first one's already done. X equals 0. Add the 8 over. We get x equals 8 for the other one. Well, let's see. We have x is 0. We would have that as a length, and you can't have a length of 0. That would mean it doesn't exist, so only the 8 is what we'll work with. And they wanted us to find BD. Well, BD was 2 times x, so BD will just end up being 16. That's it for this video. Be sure to do the homework and turn it in before class time tomorrow. Have a great rest of your day.